Welcome to this video on the topic of statistics. In this video, we're going to have a look at how we can represent data using something called a stem and leaf plot. Now, a stem and leaf plot is a practical way of representing highly diverse discrete data. Now, if we turn our attention to the data set shown over here, what we have is the set containing the age of people who attended a classical music concert. What we're going to do is we're going to represent this data on a stem and leaf plot. Once we've completed drawing the stem and leaf plot, we'll be able to observe the distribution of the age of the attendees of the concert. Now, the first sort of stem and leaf plot we're going to draw is something called an unordered stem and leaf plot. It's called unordered because the numbers on the actual plot itself are not going to be in order, as can be seen with the unorderedness of the data in this set here. Now, the first step for drawing a stem and leaf plot, we first write the word stem, and then we write the word leaf. After that, we get a ruler and we're going to rule a straight line that separates the stem from the leaf. Now, we need to turn to our data. What we're going to do is we're going to represent our data in terms of decades on the stem and then the least significant digit on the right, so the ones on the right. So what I need to do is I need to look for the lowest decade we have available. So I have a 4, then I have a 3, the 5 is bigger so I ignore it, 6, 5, 6, keep ignoring the numbers that are bigger than 3, we have a 2, and then finally we have a 1. So 1 is the lowest decade. As a result, under the stem, I'm going to put 1, and then I'm going to count up to the biggest number. So looking at this, my biggest decade is 6. So I'm going to count from 1 to 6. And thus I'm able to trim my stem ever so slightly. Alright, so I've set up my stem. Now the next part is I need to start populating the leaves. Now to do this, what I'm going to do is go one by one and tick off all of the data inside this data set here. As I'm ticking it off, I'm going to add the leaves. I'm going to add the least significant digit here to my leaves. So the first leaf I'm going to add in is 6. This is representative of 46. Then I'm going to go 32, 57, so I go 5, and then 7, 61, 50. So what you can see here is I'm trying to space everything out in an even manner. Reason for this is if I don't space it, then I'm not going to be able to see the spread of the data very accurately. So I'm going to do this for the rest of the data set now. Alright, the data is now in my stem and leaf plot. The final thing I need to do to finish this off is I need to draw the scale. The scale is going to represent what the data inside the plot actually means. So to do this, I write the word scale, then I pick any particular point within the stem and leaf plot here. Doesn't matter where the data comes from, we just have to show some sort of example to show the reader how to interpret data from this plot. So in my case, I'm going to pick 42. So I write 42. It's represented as shown here, but when we have 4 bar 2, it's representative of the number 42. So what we've got here is called an unordered stem and leaf plot. The reason for unordered is that the leaves themselves are not ordered. Now the other sort of stem and leaf plot we can have is called an ordered stem and leaf plot. The way in which this works is the stem is ordered like before. However, differently to what we saw before, the leaves on this stem and leaf plot are going to be put in order. Now for the first one we have 6 and 8, so that's unchanged, but for the second one, 7, 3, 6 is going to turn into 3, 6, 7. Going down, we're going to have 2, 2, 3, 5, 8, 9, 1, 2, 3, 4, 4, 7, 8, 0, 2, 3, 4, 4, 6, 7, and then finally 1, 2, 3, 5, 7. Now once again completing this, we need to draw in our scale. Again, picking any random number I want, I'll go in this case 5, 3. And as we can see, the interpretation of 5 and 3, as seen over here, is simply 53. So what we've got is an unordered stem and leaf plot shown over here, and then its ordered stem and leaf plot shown on the right here. Now, as well as doing these stem and leaf plots I've shown here, we can also compare data by drawing what's called a back-to-back stem and leaf plot. Now, the advantage of drawing a back-to-back stem and leaf plot is so we can make direct comparisons between the data itself. Now, consider if we have two data sets. One data set representing the typical age of rock aficionados, and the other one showing for classical music aficionados. What we're going to do is we're going to draw a back-to-back stem and leaf plot representing both of these data sets so we can make some comparisons based on the age of the people who like this music. Now, the way in which we do this is slightly different to what we did before, however the general gist is the same. What I'm going to do is, and I'm going to set it up and say, well, my first data set is for, let's go rock. So I'll write rock over here. Now the second data set is going to be classical music. Now I'm going to leave a little space for my stem, and I'll put in classical. Now I'm going to draw my stem in by drawing a straight line down the middle. And we've set ourselves up for success now. Alright, next step is I need to identify the lowest age or the lowest decade of the age. So what I'm going to do is I'm going to look through both of the data sets and look for the smallest number. So we've got 15 as our candidate, and we'll scan along and see if anything lower than 15. So there's nothing lower, so the first point or the first stem we're going to put in is 1. Now we need to look for the largest. Now by inspection, what I can see is that the largest number is going to be 67. So I'll put a 6 down the bottom here. We don't need to represent any stems or below 1 or above 6, and the reason for that is there's no data that's going to go into those stems even if we did. So it's not wrong to put them there, but it's not useful either. So we'll just leave them off. Now next step is I'm going to add the data in for the rock. Now to do this, rather than growing in this direction, what we're going to do is we're going to grow in this direction, so moving left. So adding them in, we're going to go 1, 5. So we've got the first set of data points in our first stem. What you might notice as well is both of these data sets are in order. Now going down, we're going to go 2, 3, 4, 5. Let's add it in. So the stem and leaf plot for the rock aficionados is now complete. Now we're going to go for the classic. Now, final thing I'm going to annotate on this is the scale, so it's interpretable or understandable for people who didn't create this, so basically everyone else. Now again, just picking a random point, I'll go, and 3 bar 2 is of course equal to the age of 32 years. Now one of the classical things about this back-to-back stem and leaf plot is that it enables us to make comparisons between the two data sets that have been plotted. Now in the case of these two data sets, the age of the rock aficionados and the classical music, is that you'll notice that the typical age of the rock aficionados is younger than that of the classical music aficionados. So the power of the back-to-back stem and leaf plot is we're able to compare data sets. So in summary, what we set out to do in this video was we wanted to look at what is a stem and leaf plot and how we can create them. We first looked at the unordered stem and leaf plot, closely followed by the ordered stem and leaf plot. Then finally we had a look at the back-to-back stem and leaf plot, where we found that by creating back-to-back stem and leaf plots, we're able to directly compare two data sets.